In the self-assessment number 2, I've asked you to write a small program to compute the values of a standard physics formula, something you might have done in a high school physics class, for example. This is a common challenge for programmers, is to take equations from the physical world and write programs to produce those same values. It's certainly more efficient than using a calculator. Let's get started. We want to have some formula that will ultimately deal with the fact that you've got pressure times volume equals n the number of molecules times R times T, where R is a constant, T is the temperature. If I start with this information, then to write a program, I need to write, let's say, the simplest program that I need. And here there's no need to get any input from the user from a keyboard. I have a number of constants. As it turns out, I don't even have to define a function. Let's just come up with some variables and let's just do some work. I know that I'm trying to compute n. So this means if I do some quick equation changes, I need to have an equation that looks like the form n is equal to p times v, whatever those values are, divided by r times t. So to make this work, I need to define what these variables are. I know my pressure is equal to 1.4. That's in ATM. I imagine that looks fine. I need to have the volume, which would be V. This is in 500 milliliters, but we have to be careful. This formula is expecting it to be in liters. That's what the L here stands for. So I can't just use 500. 500 milliliters is half of a liter. So I can just do this. This would give me half of a liter. Or I could just go right away and just say, well, I know that's 0.5. In any event, you can't just do 500 divided by 1,000 because those are two integers. And using integer division, this would actually be the value 0. You can test that out easily enough by just typing in and asking Python using a calculator, what's 500 divided by 1,000? And I know it looks distinctly odd, but this is the same value you would get in another programming language like C or Java, or even MATLAB. And that's why I'm sticking firm to my principles and trying to show you code snippets so that when you move on to MATLAB, you'll be ready for it. So let's go back. I know I've got 500 milliliters, but this is actually 0.5. And I can make little comments here to go along with my code. Anytime you put a pound sign in your code, you're saying that this is code that I'm typing in not to be executed, but to be read by humans. Finally, my temperature is 20 degrees Celsius, but this is looking for Kelvin. And if you remember, to compute Celsius to Kelvin, you have to subtract absolute zero. So let's imagine that we know what the value of absolute zero is. It's actually not that hard to do. Let's just do a quick Google search on this one, and we'll say absolute zero. Google should come right back with it. If not, Wikipedia has it. And absolute zero is minus 273 in Celsius. So I have to remember that my temperature is whatever the value is, but again, I have to make sure I get down to 273 degrees. So let's make sure we got this right. If you're in Kelvin 0, that means absolute 0. So Celsius of, let me just pause this to make sure I've got this right. Turns out I have it slightly backwards. To convert Celsius into Kelvin, you have to add 273.15. This makes sense, after all, because if you're at absolute 0, minus 273.15, that's 0 degrees Kelvin. So I make a quick little note. This is in Kelvin. So now I have 3 of my constants, pressure, V, and T. The last one I need is R, and R is given to you 0.08206, 0.08206, and this is in liters times ATM times, negative molecularity, Kelvin minus 1. So I think I have everything in place, and now this computes n, which is this value. I want to save this and run it just to show you. You may see something like this when you do your own code. It looks like my program is done, but when I run it, there's no output. The reason there's no output is that I didn't go and do anything with these values. So what I really need to do is when I'm all done, I need to print out n, whatever that value is. And now when I print out n, I get 0.0298, and that looks pretty close to the answer over there. So this completes the self-assessment. The tricky part of this assignment was to make sure you had all the units properly documented, because after all, the equation demanded them to be in liters and in Kelvin,